All right, here's the practice lesson for Unit 7, Lesson 5. And it's just a little bit more grind. Um, it gives us. I went and drew a bunch of practice triangles. They're not to scale at all. I color coded the other page when I realized that none of these were color coded, but I'm going to use my color coding here. This will be for my left and right, my x-axis. Red's going to be for up and down, my y-axis, and then hypotenuse will be z, and then my neutral color is going to be purple. Okay, that's the pattern I'm going to try to stick to. And I'm going to try to show you guys a different way to label these triangles and help you see a different way to read the line segment names and stuff like that throughout this thing. Okay, so don't try to do these without drawing a triangle. You're just gonna be hurting yourself or making it harder for yourself. Okay, so I'm gonna use my neutral to note the vertices here. Okay, so I have measure of LPG. So I have a triangle. It's PGL. Right, it's right triangle, but LPG is 90 degrees, right? So that's 90 degrees. So my angle P here, right? It's a one of those triangles. All of these are just one of those triangles that have each vertex only has two lines coming out of it. So I'm just gonna that's angle P. Okay, that's 90 degrees. That's my 90-degree triangle, right? And this is L, and then this will be G, right? Because I said so. Okay, so LG. I mean it doesn't have P in it, right? So that has to be the hypotenuse because it's opposite P, right? So this is P and this is 17, right? So this is 17 here. Right, you can also call that lowercase p if you want to, because it's opposite the big one. Okay, and LP is 8, so that's going to be G, right? The lowercase g. Right, that's opposite of that, so that's my y value. That's up and down. That's G, also known as 8. Right, so I don't know L, which is going to be my blue value. I don't know L. Okay, so how can I figure out? Okay, it's asking me to determine the measure of G. It's asking me to determine G. All right, so how can I figure out G here? Okay, this is also my theta. All right, so I have what is G? Well, I have what function do I need to figure out G? Okay, it's not asking me to figure out L or anything like that. It's just asking me to figure out G. Okay, well, G is, I have the opposite length, I have and I have the hypotenuse. So that is the sine. Why did I use, this should have been red. 8. Oh, that is red. Okay, that looks orange. Anyway, all right, so the sine theta, the sine of G, big G, angles are big, line segments are little, equals 8 over 17 over 17. Okay, so the sine of G equals 8 divided by 17 equals 0.47. I'll round that up to 1. 0.471. Okay, so if I want to figure out what G equals, so G is going to be equal to arc sine of 0.471. So maybe 0.471 inverse arc sine. G is going to be equal to 28.1 degrees. 28.1 degrees. So there you go. That's the way I did that one. Okay. So you probably get even more precise if you want 8 divided by 17, and then did the arc sine of that, you get 28.702. That's even more precise, right? But so I mean, that's if you wanted to be even more precise, you know, it'd be, this is approximately, right, and closer is 28.072, but you know, you can only get so close. See the difference between rounding, right? A little difference between rounding there. You're off by 3/100ths of whatever measurement you're taking. Okay, so moving on to this one. All right, I got triangle BLC. Angle C is my right angle, right? And I'll have B and L, or L and B and L are the other two, B and L. All right, so then it says B and C, so this is angle L, 33. This is 33. L and C, so this is the hypotenuse of B. All right, so the hypotenuse is 56. Okay, what? Oh, it actually told us how to use it. I didn't read the whole question. Okay, all right, so you're using find the measure of B. B is our theta, right? Using the tangent ratio. Okay, so let's double check to make sure. They gave us BC and they gave us LC. LC, that's not B, that's, there you go. It's still B, but this would be little c. That's little c. Little c. Little c. Oh, I should make it like a cursive-y looking C. Nothing to do with the problem at all. Okay. But this is 56. This is blue. This should be blue. And this is 56. Right? So the tangent, so the tan of theta, so tangent of theta, I was going to say tangent of theta, or B, tangent of B, equals opposite 56 over adjacent equals 56 divided by 33 equals 1.69696969, repeating 69699, repeating, and then I'm going to take the inverse tangent of or the arctangent of that, and so beta, angle beta equals 59.59. I don't know why I used red. 441. 59.50. 4898. Yeah, that's accurate-ish. Okay. All right, so now we're gonna move on to the next one. 9 minutes in. That's 5 minutes of problem. Okay. All right. Determine. All right. So we're gonna do angle DZM's 90 degrees. All right. So Z, D, and M. All right. We are trying to figure out like the ZM. So we gotta figure out this. MD. So the hypotenuse is 41. DZ is 9. Well, it's easy. You got a Pythagorean theorem. Okay. All right. So we got to figure out our Pythagorean's theorem states that I'm going to say that this is angle D here, right? This is lowercase d because it's opposite of big D, right? So lowercase d squared equals our hypotenuse squared z squared minus m lowercase m squared. Lowercase m squared. Right, that should be red. Lowercase m squared. Right, that is this one, this length. This is lowercase m because it's opposite the big M. Right, it's also my y. Okay. Right, so this is my D because it's opposite of the D, the large angle, the uppercase D here. This is the lowercase. The line segment is a lowercase d. Okay, that's how you pair up the angles and the line segments. This would be little c, okay, if you haven't gotten that yet. All right, so just plug and chug here. This is Pythagorean's theorem, right? It's just an alternate form of it, algebraically. So I'm going to say that z squared, so it's going to be equals, it's going to be equal 9 squared. No, that's not right. 41 squared minus 9 squared equals 41 squared minus 9 squared equals 1600. So d squared equals 1600, and the square root of 1600 is 40. So d equals 40. Okay. I'll just say d equals the square root. Some more work there for you guys. D equals the square root. 1600 equals 40. Okay. All right, so here we go with this one, grudging along. We still have this one, so I can erase this. Still using this big triangle here, so I now know that this is 40. Man, this is a tiny, skinny triangle. Okay. Now I got to figure out the angle D. I want to figure out this angle. All right, so this is gonna, and I have to use the tangent ratio to do that. All right, so I'm gonna do the tangent of D equals the opposite 40 over adjacent 9. It's red. And 9, man, I can't use red because it looks like orange. Maybe let's try green next time. So 40 divided by 9 equals 4.44 repeating. I guess how's purple look? It looks like blue on the camera, right? It equals 4.44 repeating. I'll take the inverse tan of that, and that means that, or not the inverse tan, the arctan, excuse me, and therefore measure of angle D equals 77.32. Number 4, right? Yeah. Okay. All right. Now we're grudging on to number 5 here. All right, this is TKB, and T is the hypotenuse. And it gives us, and we'll do KB, sure. Okay, so KT, this is B, also known as B. Right, that's actually the red one, but you can't tell. Right, is 92. And KB, that's the hypotenuse, all because it's missing T, right? It's 115. In case you have like a better screen than me or something, I'll make that red. All right, what is the measure of TB, also known as K? What am I doing? Also known as K. What's K? Okay. All right, Pythagorean's theorem again. K squared equals T squared. T is our hypotenuse. T squared minus B squared. Equals calculator 115 squared minus 92 squared equals all right, so we'll just do what's that? 69. Okay, so K equals 69. Should be blue. Alright, so it's going to be 115 squared minus 92 squared. Okay. All right. And that's all that one is asking for. Moving on to the next page. Move this stuff out of the way and maybe zoom out. Maybe. I'll just zoom out as I go. This stuff because that's the next lesson. Hopefully my camera doesn't get jostled enough to get this plugged or whatever you want to call it. Okay. All right. Oh, this is a carry on from this one. All right. So what is the measure of K using the tangent? So K is opposite over adjacent, so it's going to be 69 over 92. 69 over 92, so the tangent of K is 69 over 92, just making sure. Determine a measure of angle K. Angle K, 69 over 92. Alright, so 69 divided by 92 equals 0.75. Take the arctangent of that. Equals 36.86. Oh, nearest thousands. Okay, so 68.870. All right, moving on to a new triangle. Whew. Looks like we only have two. Hold on, my dog's barking. All right, I'm back. I think my dog saw a squirrel. All right, moving on. We have another triangle. Looks like S is the 90-degree angle. Man, so it's PC are the other two vertices. And P is 27 degrees. And CS, that means P is 14. Should be lowercase p. Lowercase p. Okay. If I wanted to name it that. Okay. What's length of CP? Also known as S. Right, and that's the hypotenuse. Just trying to figure out the hypotenuse. That's why I write it 2. I don't know why I wrote 2. The hypotenuse, also known as lowercase s. That's my cursive s. I'll just do lowercase s. Or hypotenuse. Or z. What is z? Okay. So the function I need, it tells me to use a sine ratio, right? So the sine, this is going to be opposite over hypotenuse, right? So sine, I don't need to write that. The sine of 27, the sine of 27 equals opposite, which is 14. What happened? There it is. Dig out all my stuff. Opposite, which is 14. 14 over z. Over z. Okay, so I need to solve for z here. All right, so I'm going to multiply z by both sides, and then divide it by the sine of 27. Or when the denominator over here is what you need all by itself, you just swap these two. All right, so z equals 14 divided by the sine of 27. All right, and that makes sense because what do we know about sines? Right, the sines are always going to be less than 1, right? And we know that the hypotenuse is always the longest length of a triangle. And if you divide a number by a number that is less than 1, it's going to become longer. So that checks that passes the common sense check for our algebra. All right, so 14 divided by 27 sine equals 30.8. And it says nearest thousandths 30.838. 30.838. So that's going to be equal to 30.838. 30.838. And I'll just erase my z because values are better than variables. 30.838. All right. Now explain why neither cosine nor tangent could be used to determine the length of that. Well, we didn't know the adjacent side, right? Length of CP. The length of CP. Why? Well, we didn't know the length. We didn't know that in order to use cosine or tangent, the adjacent side, the value of the adjacent side must be known. The value of the adjacent side must be known. All right, we didn't know PS. That's the adjacent side, right? Because it's opposite over adjacent, right? So we didn't know that. you could have figured it out eventually, but it by itself, you wouldn't be able to figure it out on its own. All right, the key says, let me dig up the key real quick. All right, tangent is opposite over adjacent and does not include the hypotenuse. It could be used to find SP and then use Pythagorean's theorem. It could be used to find CP, but the tangent alone cannot be used to find CP directly. Okay, yep. SP. Yeah, that's what I said. Because we didn't know either one of those. Yeah, so it's saying that we couldn't have figured out. We can't use tangent to figure out the hypotenuse because it's not part of it, and we could have used cosine to figure out. We could have used cosine to figure out this, and then we could have used Pythagorean's theorem to figure out that, but it would have been a double step type of thing, right? So, yeah, so that's what that's saying. It's kind of a, I mean, you technically could have figured it out with cosine and then tangent, but or tangent and then cosine, but it's a tricky question, I guess. All right. So, all right, moving on to the next one. Okay, you have a triangle, angle T. Angle T is the 90-degree angle, and then the other two are N and L. Okay, and then we got angle N is 33 degrees, and then T is not involved in that, so T is 157. That's the hypotenuse. 157. Also NL, right? 157. Oh, it doesn't tell us what we have to use. Awesome. Great. All right, now we've got to figure out what length N is. Wrong color. Length N is length N, also known as TL, right? Opposite of angle big, angle N, right? All right, so what function? This is the opposite length of N, and this is the hypotenuse. So what function uses opposite and hypotenuse? That's sine. The sine of 33 equals opposite N over hypotenuse 157. Okay, well, this one's pretty easy. You just move you multiply both sides by 157, and then you get N equals 157 times the sine of 33. And let's see if that passes the common sense check. Right? The sine of any value is in a right triangle is going to be less than 1. Right? And so the sine of any value less than 90 degrees is going to be less than 1. So if I have, if I multiply it by 157 degrees, then it's going to be less than 157 degrees. Or, sorry, 157 units, it's going to be less than, N will end up being less than 157. So that makes sense. That passes the dummy check, right? By what magnitude? Who knows? Let's see, though. So 33, the sine of 33 is 54, like 55 almost, right? And then we're going to multiply that. So that means it's going to be about half as long as the hypotenuse, a little bit more. So, whoops, don't need a negative. So that means that N is going to be, n is going to be 85.5 as the tenths, 0 hundredths, and then I got 8. That's the thousandths, right? So this is now 85.508. All right, now I got to figure out the length of the other leg, and I could do Pythagorean's theorem, but I don't want to, because that does square stuff. All right, I'm going to use cosine for that. Okay. I could use tangent, but I don't want to either. I'm going to use cosine. All right, so I'm going to say the sine. I'm going to say the cosine. I'm going to use a different color, though. I'm going to use red, because I'm using the adjacent leg. The cosine of 33 equals the adjacent leg, which I don't know. This is going to be L, right? Also known as NT, right? L divided by 157. Adjacent over hypotenuse. Right, way easier than Pythagorean's theorem. Right, or I could do, which one? Let's see which one you'd rather do. This is using trigonometry, or I could do L squared equals 85 or 157. 157 squared minus 85.508, which is a rounded number, squared. And then I take the square root of that. Which one would you rather do? I think I'd rather do this one. So anyway, algebraically rearrange this one here, and I'm going to say 157 times the cosine of 33 equals L, which equals, well, you can't see that. Scooch it over a little bit. There you go. So cosine of 33 times the cosine of that times 157 equals 131. 131.671. And just for funsies, let's do it this way. 157 squared minus 85.508 squared equals squared 131.671 for, yeah, I like that better. It's fewer buttons and less likely to hit a button. L equals 131.671. Either one would have worked. So there you go. That's all of it. The key does it this way, by the way, since I'm looking up at it now. The key does it this way. You could have done it this way too. Either one works. Pythagorean's theorem still holds true. So hope you guys learned something from this, and it that was 34 minutes. We should be just short of 35 minutes for that one. So 35-minute homework ain't too bad. And that was with me talking and changing colors and all sorts of different stuff. This should have been a 20-minute homework, easy for you guys if you knew what you were doing. All right. So anyway, I hope this made lots of sense. And if you don't understand it, come talk to me at school and we'll punch through it.